Hello, this is my report for Lab 3. I used computational modeling to analyze a black hole system and then navigated a spaceship through a complex planetary environment using Newton's second law. In part 1, the star was my system and the black hole was the surrounding body. Using a time step of 1 Earth day in seconds, I analyzed the star's momentum changes to find the net force. My code printed various values for the mass as the star moved. By looking at the data, I found the mass to be approximately 1.25 times 10 to the 34th power kilograms. I average these values because the mass should be constant and any slight variations are due to the discrete nature of the data points. How does net force differ from the rate of change of momentum? While numerically equal, they are conceptually different. Net force is the cause, the gravitational pull. The rate of change of momentum is the effect, the motion we can actually see and measure. We use these observable changes in speed and direction to calculate the hidden gravitational force acting on the star. In part 2, the spaceship was the system, and the planet and the moon were surroundings. My goal was to launch from the moon and orbit both bodies. Using an initial x velocity of negative 500 meters per second, I was able to maintain a fancy orbit for exactly 4,500 hours without crashing into the moon or the planet. My spaceship achieved a Rosette-style orbit, showing the influence of both the planet and the moon over the 4,500-hour mission. For error analysis, three-body systems are extremely sensitive. A tiny change in initial velocity would cause a crash, as seen in my early trials where I crashed into the moon after only 357 hours. Additionally, using a large time step of 1 day in part 1 can lead to small rounding errors in the final mass calculation. If we modeled the entire system including the black hole, we would have to sum the gravitational forces for every possible pair. While the black hole star force is the most dominant, a truly accurate model would include the black hole's subtle gravitational pull on the spaceship and the moon as well. That concludes my report.